everyone, so this is Mrs. Slauson, and here is our video for Monday. We're just going to practice a little bit more with graphing these polynomials, and you're going to see some are in factored form, some are in standard form, and when they're in standard form it might be factorable, but it might not be, and then we have to use that rational root theorem. Alright, so just a heads up, don't expect to have your graphing calculator when we're graphing. So let's get started. So we are in week 5. And we are going to find, so you're going to see your equation at the top, A, B, C, D. There are quite a few, but your steps are going to be over here, and then your work's just going to go over here. And you can just ignore the lights. The idea was, you kind of give me a red, yellow, green where you're at, but I'm not going to do that. So the first thing I'm going to do is just find all the zeros, and I'm going to determine if they bounce, wiggle, or cross. I'm able to do that really fast because it's in factored form. This is the nice thing about factored form. So according to this one of my zeros is 1, and it shows up 3 times because there's technically 3 of these x minus 1s. So that would give it a wiggle. Then I have a -2. It shows up once. That's a cross. And then I have -1 twice, which shows up as a bounce. Now I'm going to find the y-intercept. All y-intercepts are when x is 0. So if I go to my function and I just put 0 in wherever there's an x, I'll be able to do this. So first I get -1, and -1 cubed is -1. And when I multiply or add this up, I get 2, and when I add 1 and square 1, I get 1. And then when I multiply these, I get -2, so my y-intercept is at 0, -2. Next, I also want to think about the leading coefficient to test and determine the end behavior. Basically, I want to know the shape. And so first, it's positive in front. So I know it's not flipped, but I want to count how many x's there are to know if it's a bumpy line or bumpy U. So I have 3 x's here. 1 more x there, there's 4. 2 more, that's 6. So there's a positive something, x to the 6. I'm not going to worry about what number is. I just want it positive, which says it's going to be some type of bumpy U. So when I do my end behaviors, they're going up, they're rising up on both the left side and the right side. Left side and right side. And now I'm going to sketch the graph. So again, when I sketch the graph, I hope I have a pencil because I've been giving them all away. I'm going to take my zeros, so here's 1, and just a reminder, it's going to wiggle. I have 1 at -2, which is going to cross, and then I have 1 at -1, which is going to bounce. And then I have my y-intercept of 0, -2, so somewhere down here. And where I like to start is the end behavior. So on the left, on my farthest left point, I know it's going up. And then this is the farthest right point, so this is left, then over, then the next one over, then the furthest to the right. And so that's going to be going up. And then I just have to get from this point to this point to this point to this point. Connect the dots left to right. And so when I start here, it's going to cross through the x-axis. It will turn somehow. When it gets to here, it's going to bounce, come back down. I'll just have it turn right into it. And then when it comes up, I want to have it wiggle its way across. So I'm going to go back and now erase this so I can definitely see that wiggle. Not quite like that, but something like that. All right? So let's go to graph B. So in graph B, I need to find all the zeros and then determine if it bounces, wiggles, or crosses. So first of all, this is not in factored form. So I would try to factor this. But in order to factor this, so first of all, are there factors of 32 that get me to 6? So just real quick, because I don't have it up there, if you wanted to see. These are the only factors of 6, and none of them are going to get me to 6 anyway. But this isn't factorable because this would have to be an x to the 4th for that to be an x to the 2nd. And so this is not factorable. So what I need to do is make my list of numbers. So I'm supposed to take factors of 32, -32. So I'm going to do that over here. So I get 1, 2, 3, 4, 5, 6. Well, I actually had them here. 1, 2, 4, 8, 16, and 32. And again, there's a positive and negative of all of these. And then I should take the number in front, which is a 1. So the only factors of 1 are 1. And then I make this list of numbers where this is my numerator and this is my denominator. And so I just put all of these over 1, which just gives me, in the end, a positive and negative 1, 2, 4, 8, 16, and 32. So I should start testing those numbers till I can get one that works. And remember, it works when I get 0 at the end. So first, when I put my numbers in here, I need to have my countdown, the third power, the second power. I'm missing the first power, so I'll put a placeholder in and then just the plain number. So there's 1 for the first power, there's 6 for the second power, here's my placeholder for the first power, and then my plain number, and remember, I should get 0. So I've already done this, I already know which one's going to work, and a number that's going to work is -4. So I'm going to start and bring the 1 down, start multiplying. I'm going to add these up, multiply again, add these up, multiply again, and sure enough, I get 0. So that means I have one of my zeros, -4. Now, if I really want to know the factor that got me there, I'm going to go ahead and write that down. That would have been an x plus 4. Okay, just a heads up. But now what I'm going to do is take this, and I don't need this. This told me that it worked. This is the constant. This is an x, and this is an x squared. And now what I'm going to do is take x squared plus 2x minus 8, and I'm going to factor it because there's 3 terms. So I make my x, and I need factors of -8 that get me to 2, and that would be a 4 with a -2. And notice I'm putting x's with all of these. And now I'm going to go straight to my factors. And what neighbor meets what neighbor to make x squared? Well, that's just an x and x. And then I draw my loops, right? So and again, I'm focusing on these. Can I take x times something and get 4x? I can. That's a plus 4. And then can I take x times something to get that? And that's a -2. So now I can add to this factor another x plus 4, or I could have written it once with squared, along with the x minus 2, and now that one gave me this, which was this. Then I have another -4, and then I have a 2. So the -4 will be, if we want to put it here, my bounce, because it shows up an even amount of times, and this shows up once, so this is going to be my cross. The y-intercept is super easy in standard form, because if all y-intercepts, have an x of 0, and I put 0 in here, then 0 cubed plus 6 times 0 squared minus 32. Well, that's just 0. This is all just 0. And then when I subtract 32, I just get -32. So my y-intercept is 0, -32. I want to use the leading coefficient. I actually want to use the leading term to know the shape. It's an x cubed, a positive number, so this is a bumpy line going uphill. So on the right, it's rising, and on the left, it's falling. And now I'm going to make my graph. So first, I go to -4. That was one of my zeros. That was a bounce. And then I go to 2, which is another 0, and that's a cross. And then I go to my y-intercept, which will be way down here of 0, -32. And now I'm going to do my end behaviors in pencil. So I know on the left side, this is the left side, it's falling. And I know on the right side it's going up, because this is the left point, next point over, final point over. So now I'm going to do this. So I'm going to follow this, and when I get here, it's going to bounce off. At some point, I can come down further, but I'll have it turn to get to here, and then it's just going to cross right through. Again, we don't care about where it turns, you just want it to turn somewhere. So there's B. Let's take a look at C now. So this one is in standard form, which again is good for many reasons. But what I'm going to have to do is find the zeros, which means I'm going to try to factor this. So I don't notice a GCF, but I can make an x out of this. So factors of 5 that get me to -6. Now you got to be, well, it's just 1 and 5, right? And I'll have to make sure that these are both negative. So when I multiply these, I get the 5 with the x to the 4th, and when I add these, I get the -6 with the x squared. And then I can go straight to my factors. And again, what neighbor would meet what neighbor to make x to the fourth? Well, that's just an x squared and an x squared. And then I draw my loops. So can I take x squared times something to make this? And that would be a -1. And then can I take x squared times something to get to that? And that would be a -5. So this is one of those cases where I can factor further. This is not a difference of squares, so I'll just leave this one alone. But this is a difference of squares. This can become x plus 1 and x minus 1 because the square root of this is x and the square root of this is 1. So now what makes them 0? Well, this is 1. This one is -1. And when I set this one equal to 0, I'll want to add 5 and then take the square root of 5. And the square root of 5, remember there's two answers. It is the square root of 5, but it's, it's about 2 point something. So there's a positive and negative 2.2 something. So the question is, how do I know it's 2 point something? Real quick, if I'm trying to figure out what number times itself can get me to 5, well, I don't know, I drew a number line. I go with the numbers that I can do. So 1 squared is 1, 2 squared is 4, and 3 squared is 9. So that means what number squared would give me 5? Well, it's got to be in between. If 2 squared gives me 4 and 3 squared gives me 9, that means 2 point something would give me 5. Okay, so 2.2 positive and negative. And these are all showing up. I don't know if it's actually 2.2. Let me find out. I shouldn't say that. I do have a calculator. So it is. It's 2.2. These all show up once, so they are all going to cross, just one big C. My y-intercept, again, is when x is 0, and if I just put 0 to the 4th power minus 6 times 0 to the 2nd power plus 5, sorry, you can see that. Well, again, that's 0 minus this is all 0 plus 5, I get 5. So my y-intercept is 5. It says leading coefficient. It should say leading term, which is x to the 4th. So it's a u and it's not flipped. So it's rising on the right and rising on the left. And now I'm going to go over here and put my points. I really don't care that I don't like the numbers there because my points are going to be really squished in there. But I got a -1 and a 1 and about a 2 point something and a -2 point something. And these are all going to cross. And then my y-intercept is up here at 5. And again, my end behaviors, I go to the furthest left point, I go to the furthest right point, and now I'm going to go from this dot to the next one over, to the next one over, to the next one, to the next one, and it will cross through. I'm going to have it turn somehow, cross, go up here, just have it turn, cross through here, have it turn again, and cross up. All right, that is graph C. Let's take a look at graph D. So in graph D, again, this is in standard form, which is great for many reasons, but I am going to try to factor it. And the first thing I notice is that I can factor an x out. So there's the GCF of x, and then this is what's left. And this is what I'm going to try to factor. So since there's 3 terms, I'm going to make my x. So I need factors of -12 that get me to -1, and that would be a -4 and a 3. So joining my GCF of x will now come my new factors, or my new neighbors. And again, what neighbor would meet what neighbor to make x squared? Well, that's an x and an x. And then I use the side numbers to figure out the rest. So can I take x times something to make this? And I can. That's -4. And can I take x something to make that? That would be a +3. And that's it. There are no difference of squares here. So what's going to make them 0? Well, we'll make this 0 is 0. What will make this 0 is -3, and we'll make this 0 is 4. These all show up once, so they're all going to cross. My y-intercept, again, is when x is 0, so if I take 0 cubed minus 0 squared minus 12 times 0, well, then I just get 0. So my y-intercept is 0, 0. What would the shape be? Well, when the leading term is x cubed, this will be a line that goes uphill. So it's rising on the right and falling on the left. And now I'm going to go to my graph and put my points. So first, here's a 0, here's a 0, and here's a 0. And then I actually already have my y-intercept. And again, these are all crossing. I can remember that. My end behaviors, it's going down on the left and up on the right. So I just got to go from here to here to here. So I'm going to go up, turn. It's just going to cross right through, turn, and come up. Again, you can have it turn wherever you want. All right, next one, E. So on E, again, standard form, so I'm going to try to factor it. There's not a GCF. So when I do this grouping method, I'm going to take out an x squared, and then I'm left with an x minus 1, which if you remember needs to be an x minus 1 here. And that means what neighbor would meet x to make this? Well, that would be a negative 14, but negative 14 can't meet this and get 24. So this is not factorable. So not factorable. And that means I need to come up with the list of numbers. So again, I should take the factors of the end, 24, and those factors are 1, 2, 3, 4, 6, 8, 12, and 24. And then I should take the factors of the number in the front, which is just 1. And when I make this my numerator and this my denominator, it's 1 over 1, 2 over 1, 3 over 1. So these numbers just repeat. And I've got this long list of numbers that I should be checking when I make that upside down division box. So I'm going to make the box, check my countdown, 3, 2, 1, nothing. So I'll put 1 and negative 1 and negative 14 and 24. I'm just taking these numbers that are here. And so I would like, a number that's going to work right away. So a number that will work right away is a 2. I've already checked it. And I'm going to bring this down. And 2 times 1 is 2. I'm going to add this up. 2 times 1 is 2. Add this up. Negative 12 times 2 is negative 24. And I get the 0 that I needed. So remember, this tells me that it worked. It tells me that 2 is a 0. A factor that would have gotten me there, just a heads up, is an x minus 2. But now I'm going to take this stuff and put x's to it so I can factor. So nothing, x squared. So now I'm going to factor x squared plus 1x minus 12. And hopefully we're getting better with the x, but I need factors of negative 12 that get me to 1. Sorry, you can't see that. And that would be a 4 with a negative 3. And so now joining this factor will become the new ones. And again, x has to meet x to make x squared. And now I'll draw my loops. So can I take x times something to make this? And that would be a plus 4. And then can I take x times something to make this? And that would be a minus 3. So adding to this 0 would be a 3 and a negative 4. They all show up once, so that's a cross. Again, the y-intercept when x equals 0, so I would have 0 cubed minus 0 squared minus 14 times 0 plus 24. And that's 0 minus another 0 minus another 0, adding to 24 gives me a y-intercept of 24, 0, 24. And then from there what I can do is get my shape. So the x cubed tells me that this is a line going uphill. It's rising on the right, going up. It's falling on the left. It's going down. And now I'm going to go to my graph and put a point at 2, at 3, at negative 4. They're all going to cross. And my y-intercept way up here. And again, if I know the end behavior on the left side, this is the furthest left, this is the furthest right. It's going down and it's going up, and they're all just going to cross. So get from here to here to here to here. So it will cross through, have it turn at some point to get to here. It's not very good. And then it's going to work its way to 2, cross through, turn, cross through. Again, your picture doesn't have to look just like mine, but they should look somewhat similar. Like I could have this go way down and then turn. All right, is this the last one? Graph. All right, so the first thing I'm going to do is it's in standard form, so I'm going to try to factor it. I notice there's not a GCF, so I'm going to group them. And from here, I can take out an x squared, and I'm left with x minus 2, which I'll make the other one matching. And what would I have to factor out of this to get to here? It would be a negative 9. So negative 9 and x make that, and negative 9 with the minus 2 make the 18. So now this one's factorable. So one factor are those things on the outside, x squared minus 9, and then my matching set is the other. And again, every time I think I'm done, is there a difference of squares? And there is. This can become, because this has a square root and this has a square root, so this can factor further into x plus 3, x minus 3, and then the x minus 2 just comes along. Okay? All right, so now what will make this 0 is negative 3. What will make this 0 is 3. What will make this 0 is 2. These all show up once, so they're all crossing. My y-intercept, once I put 0 in for x, I get 0 cubed, minus 2 times 0 squared, minus 9 times 0, plus 18. And these all become 0, except for the 18. And when I do that math, I get a y-intercept of 0, 18. This is an x cubed as my leading term, so it's a line going uphill, so it rises on the right, falls on the left, and then I'm going to come here and put a point at negative 3, at 2, and at 3. Here's my y-intercept of 0, 18. I like to draw in those end behaviors, so it's going to go down here and up here, and it's going to cross, go to here, cross, go to here. So I'm going to go up, I'll go up higher, come down, cross right through it. I'm not very good at doing this. Comes over, crosses, turns, and there you go. And that is your practice for Monday.